This live Slooh show is brought to you by the support of Slooh members and the following sponsors. Visit slooh.com to become a member today.
Yeah, it does. And actually, I think sometimes if you get a very, very thin veil of like light cloud, one of the things it can do in astro images is really bring out the star colors, which are particularly beautiful, I think, in the summer night sky. Just at the bottom of the screen there, you've got Antares and Scorpius, and that's that gorgeous orangey color. And then I know we're going to talk about the stars elsewhere in the frame tonight, and you can see how different colors they are. Oh, absolutely. I mean, Vega, Altair, and also we can consider a third that you can just see on the screen there. On the far left is a very bright star called Deneb, and together these three stars are incredibly bright in the summer night sky, and they make up what we call colloquially the summer triangle. It's a beautiful, a huge triangle that stretches right across the Milky Way and across several constellations, in fact. So Vega at the top there is part of the constellation of Lyra, the Lyre. Alta is in the constellation of Aquila down there in the south. And then right across that, you've got that lovely, beautiful, misty light, the Milky Way, that we could see so clearly in our live or sky images from the Canary Islands. Oh, there's a huge range of objects across this beautiful swathe of the Milky Way. Everything from clusters of stars, some tight balls of stars, which we'll, I'm sure, talk about in more detail later. But something actually you said, Eric, made me think that there's a lovely parallel between your story and the sort of mythology and also what we do as amateur astronomers and astronomers when we look at the night sky, because there's something we do with whether it's binoculars or with telescopes, and that's star hop. And we can do it tonight as we're going across the night sky. We can look and basically jump from star to star to look at our different objects. So you said we started off with the stars Vega and Altair. Well, Vega is perhaps one of the most interesting stars in the night sky. I mean, it's incredibly bright, fifth brightest star in the night sky, in fact. But also scientifically, it's been one of those stars that have really thrown up some real surprises for astronomers. So one of the things that happened is when the early infrared space telescopes looked at Vega, they noticed that there was an awful lot of infrared light coming from the star than what they should expect than just a normal image of Vega. And what it turned out to be is actually a large disk of dust around it. So in a little way, we've got dust flying over the Canary Islands tonight, sort of impeding our view. But in fact, when astronomers looked at Vega, it was dust that really excited them. It was something that they were really pleased to see because it's thought that maybe Vega has this sort of the planet forming disk, what we call a protoplanetary disk around it, where maybe there are collisions of planetesimals. So, sometimes dust is good in astronomy. Certainly, star forming, you need a lot of dust. But sometimes for us here, like we are on Slooh, where we're trying to look at the night sky, it can be a little bit problematic. So we've got all these different types of stars in our galaxy. Our galaxy is made up of somewhere in between, we don't know for sure, somewhere between 200 and 400 billion stars. And if we look in this all-sky image, we get a sense of where those stars are distributed. So if you look across the sort of left-hand side of the image, we see that lovely milky misty band. And that milky misty band, for the most part, stretches out across, in this view, across the northern hemisphere, and in the southern hemisphere, astronomers see it going the other way as well. And that forms, well, what we're seeing there is essentially the spiral arms of our galaxy edge on. And if you imagine, if you can put me on screen, maybe Eric, I'll just I have a little. If you imagine the Milky Way as this CD, a little CD, then the disk of the galaxy, what we see as the spiral arms, would be sort of if we were inside the CD looking outwards. And so we see the disk of the galaxy. This is what we see in those beautiful star fields. And at the center, there's a large, what we call a nuclear bulge, or a central bulge. But globular clusters, they're located above this disk and below it. So they're sort of swarming around it. And they're often likened to bees swarming around a hive, or flies swarming around a hive, because they're essentially, they sort of have these positions that are far away from the disk. Hey, we've got some live images. Fantastic. Fantastic. And one of the lovely things you can see about these globular clusters that is, like many of the clusters in the night sky, they have all different shapes and sizes. And in fact, globular clusters are really quite a mysterious astronomical object. We have some ideas how we think they form. We know that they, for example, must be some of the oldest objects in the universe. In the case of M71, that's somewhere in the region of 8 to 10 billion years old. Now, when you think our sun is only 4.5 billion years old, and the universe itself is thought to be 13.8 billion years old, you can see that these are really truly ancient objects. And so they must have been the first objects to form when the Milky Way was very, very young. But we don't know the exact process by which they form. And that is one of the intriguing sort of enigmas that we have about globular clusters. But what a beautiful view there of these sparkling little spheres of stars. I mean, if you look at M71, it's about 27 light years across. 27 light years. So if you could travel at the speed of light, it would take you 27 years to cross it. I mean, this is, from our perspective, going around the sun, we're sort of almost on our own in space, essentially, just a little star floating around in the galaxy. But in some of these globular clusters, in a volume the size of our solar system, you can get hundreds of stars. So it really does put things in perspective. When we talk about a ball of stars, we really do mean a little dense clump, a little sphere of stars. It's beautiful, isn't it? And we have to remember that these objects are extremely far away. Globular clusters, as I said, they're far above and below the disk of the galaxy. And in the case of M56, that's about 33,000 light years away, which, when you put it into the scale of the Milky Way, well, from one side of the Milky Way to the other is thought to be around about 100,000 light years. So they're a long, long way away, these objects. And yet, Slooh's telescopes, here they are, live pictures for you on the screen there, and in color as well. Yeah, yeah, we don't see globular clusters in the disk of the galaxy. That sort of thin, um, sort of well, a disk plate. If you know, if you're looking at the galaxy, that thin region where we see things like the spiral arms. So the spiral arms of our galaxy, in the case of the Milky Way, we have a beautiful network of spiral arms, and the sun sits in one of those. And the different clusters that I know we're going to go and try and see if we can get the telescopes to track them across the sky and see some of those open clusters, which is a specific type of cluster in astronomy, an open star cluster. And they're very different. They're located in those spiral arms. And so in a few minutes, hopefully we'll get some pictures of those, and you'll see that they appear very, very different. You know, these globular clusters are very compact. Typically, they have this spherical shape because all these stars are bound by their sort of collective gravity swirling around. But open clusters are often much more diffuse, much more spread apart. And over time, we think open clusters do indeed disperse because the sun was probably once in an open cluster of stars, and now we struggle, in fact, to find and find where our little sun siblings are. Ah, right. So it sounds like there's no audio coming from Eric. But one of the things I was going to mention earlier about M71. If could we go back to that chart you have, or perhaps that lovely all sky view, the live all sky view? If you've got the chart, because M71 is a lovely target for a small telescope. Actually, it's in the constellation of Sagitta, the arrow. Now, the way you find Sagitta is actually very easy. If we start off with those bright stars, we have Vega at the top there, Altair down the bottom. If you follow a line between Alta and Vega there, you can see that just down in the bottom, you can see a little collection of stars that are sort of pointing at a 45-degree angle back down to the horizon. Well, that's Sagitta, the arrow, and it's in there that M71 is nestled, sort of in those sort of Milky Way star fields. And it's a beautiful object. If you have a telescope of maybe 6 to 8 inches in aperture, you see it as this beautiful sort of almost like a little fuzzy blob, and that's very typical of a globular cluster. If you have a larger aperture telescope, say an 8-inch telescope, and you start to wander around the night sky at this time of year, there are many beautiful globular clusters. Like, for example, M13 in Hercules is perhaps the most beautiful globular cluster in the northern hemisphere night sky. And through an 8-inch telescope, you begin to see what astronomers like to call a sort of granularity to the stars. So you begin to resolve those thousands of stars, and it's really quite a beautiful thing to see. And I remember one of the most beautiful things I ever saw was a globular cluster, M13 as it was, through I think it was a 14-inch telescope with a binocular view. So in both eyes you saw this globular cluster, and you really do then get a sense of the spectacular three-dimensional nature of these globular clusters. So it's an absolutely wonderful object to look at, M71, and also a fantastic target for astrophotographers. And I think, if it, could we go back to that live view that we had uh, previously? There we go. See these color images slowly coming in, and I love this. I'm in well as Altair and Vega, you can begin to find some really interesting objects. So perhaps one of the nicest ones to look at, or actually one I really like to look at, if you have a very dark night sky, is one that's perhaps a little bit overlooked. And it's not a beautiful glowing nebula, it's not a cluster of stars, but it is what we call a dark nebula. It's called Barnard's E. And in fact, it's if you find it by basically looking at one of our bright stars, our bright star Altair that we were talking about earlier. If you find Altair, which is that very bright star in Aquila, is the brightest star in Aquila, and then you star hop to the star just above it, which is called Tarazid, you actually place your binoculars and place that star right in the bottom of the field of view. And if you have very dark skies, you can begin to make out this sort of dark patch, and that's that dark Barnard's E. And that's a lovely object to sort of challenge yourself if you're looking for a challenge. I know our members in the clubhouse really like a challenge when it comes to observing, but I'm not sure. I think we might be getting some new pictures in from the telescope. I'm not sure if Eric can hear us, but that image on the left looks like it might be one of the new open clusters that we're going on to see. In fact, it'd be lovely if we could see the open cluster compared to the globular cluster, because there's a real difference between these two different types of clusters. The globulars, as I said, live above and below the galactic disk, but the open clusters, they sit in the disk. They sit in those beautiful swirling spiral arms, and the reason they sit there is because essentially they're emerging from regions of star formation. So stars, we think, form as basically pressure waves, or some instability triggers the collapse of large dust and gas clouds, and those eventually collapse under their own gravity, and they begin to sort of, almost the gas begins to coalesce, and as it gets denser, it gets hotter, and if the conditions are right, nuclear fusion can start and a star is born. And in fact, that's how we think stars are born, in these little dense clumps that sit in these dark, dusty nebulae. But over time, they begin to glow, and of course, they eventually begin to disperse their maternal nebula. And that's when we see these young clusters embedded in these beautiful glowing gas clouds, gas and indeed dust clouds in places. And I know later on we're going to try and get an image of a beautiful object called NGC 6823, and that's a classic example of this process in action. So we'll see a young cluster of stars sat very close to this beautiful, what we call an emission nebula. So essentially the cluster of young stars is the radiation it's throwing out, because these young stars, once they begin to emerge from those maternal nebulae, they begin to kick out a lot of ultraviolet radiation. The ultraviolet radiation excites the gas around them and causes it to glow, and it glows this beautiful characteristic red color that you've probably seen in hundreds of astronomical images. You see these beautiful, beautiful sort of glowing gas clouds. So
Hi
we'll
there.
watch. Eric, can you hear me?
I do hear you.
Fantastic.
I'm wondering if the audience can hear me now. I think that was the main issue. So let me check it. So yeah, there's been I think I've really enjoyed hearing your discussions of these different astronomical objects that we've been seeing
I was
in
having
the
my own
sky.
little.
And it really, I think there's a lot to be said for how they relate, culturally to Orihime and Hikoboshi. Just as we can see if my audio is coming through now, but for now, yeah, we're moving on to the open clusters, and they're closer into the galaxy. And so, yeah, it looks like my audio is on, and so we are talking, here tonight about the two star-crossed lovers. We're talking about Orihime and Hikoboshi, Orihime being the star Vega in the night sky, and Hikoboshi being Altair, these two stars that are cut off from each other by the massive river of the Milky Way. And these are two stars that we talk about being able to have this special experience of seeing each other on just the one night, July 7th, 7/7. And it's a very special night for these two stars, these two lovers, the weaving star and the hurting star, unless it's a little rainy. And so as we've been sort of going through tonight, we've been talking a little bit about the dust that's around the night sky, and a little bit about how, if it rains, the bridge of magpies, which is how these two lovers see each other, won't be able to form. And what we're seeing in the Canary Islands, this is a scope that is 9,000 feet above sea level. It's really high up. if there's clouds, sometimes we can avoid them. It's a summer area where about 95% of the days are clear, and so we have high hopes for them being able to take this whole journey across the night sky, where we are in the middle of seeing them hop from object to object. They were at globular clusters. They're now at open clusters, and they're getting closer and closer to this object where they're going to meet in the center and have this singular reunion for this one day. And we're looking forward to sort of showing that journey astronomically as we go through these objects. And so yes, for open clusters, like we sort of were talking a bit about the largesse of globular clusters, and are these two sorts of objects on similar scales to each other?
It depends. It depends very much from cluster to cluster, really. The thing about open clusters, which I sort of briefly alluded to earlier, is that the fact that over time they can drift apart. So globular clusters tend to be bound by this tremendous, sort of contained gravity, and essentially the mass of, in some cases, we're talking millions of stars together in these enormous congregations, and they're sort of bound together in these spherical ball shapes of stars. But open clusters are thought over time to drift apart, and so this is why, in our night sky, although we see a beautiful glittering array of stars, we don't see blazing suns in our night sky. But you have to think, actually, when we're thinking about in terms of scale, let's go back to our earlier point. In terms of perspective, if you were in one of these globular clusters, your night sky would be absolutely extraordinary. I mean, calling it a night sky might be a little bit sort of disingenuous, because it would just be full of these blazingly bright stars, simply by virtue of the fact that it's so densely packed at the center. Now, if you are on the outskirts, you'd maybe have quite an extraordinary view looking back into the heart of the globular cluster. And I think even there have been some astronomical artists who've had a go at sort of painting pictures where they imagine if you're on a planet going around one of these stars in these globular clusters. But open clusters, no, they tend to sort of disperse over time. And so, for example, in M56 that we were looking at earlier, I think that's about 85 light years across. So still a huge distance across, and some of them can be much, much bigger than that.
And yeah, we have a lot of different objects that we're looking at today, and I think it gives us a lot of diversity that as we're going through the universe here. And so, one interesting trend that we can, I think we've touched on a little bit is just sort of the varying age of these objects. That with globular clusters, we're looking at the ancestors, the old age of our night sky. These things that have been existing for so long, and open clusters are a little newer. And so just like this story, Tanabata has been around for thousands of years. This is something that has been brought up and raised through cultures that have looked at the night sky and seen it through the lens of different levels of awareness of astronomy. That we've come so far in just decades that if you go back thousands of years to our understanding of the night sky, this is something that shows you our legacy, our culture. And so right now we're going to very soon be uniting these two objects, getting to the, I believe that we're coming in with an image right now of the final object on T1. And so this is, I believe, Orihime that is coming in to the object in the center that we will meet, that these two star-crossed levels will meet at together, and I think Hikoboshi will be right behind. But before we get to their united meeting, I'd like to tell you a little bit about a couple of upcoming shows for Slooh. Ones where we're really looking forward to a lot of intriguing scientific discoveries that are going to be coming up. One of them being the wonderful arrival of New Horizons at Pluto. We're going to be covering that close approach. It's been years and years in the making. I believe the mission started in 2006, and finally it's getting to the point where next week it's going to be getting it the closest any man-made object has gotten to Pluto, and we're going to be seeing what sort of discoveries can come from that. But yes, we will be covering that on the day of the close approach. We will also be covering a really fun call-in show that's just going to be right around the corner. It's for talking to Slooh members and people that are curious about comets, and talking to, our Slooh astronomer Will Gator about those comets, and getting just a little bit into more detail, and giving any curious amateur astronomer that wants to have a voice in the comet conversation that voice. And so that's coming up in just 2 days. And so look forward to that as well. But yeah, we're just coming up soon to the very final object. And what are we going to be looking at there, Will?
We're going to be looking at an object. Well, actually, I guess two objects. One is going to be a very, very young open cluster of stars. And you'll even see where it's originated from, because there's still the vestiges of its maternal nebula, this beautiful glowing gas cloud. It glows. Hopefully when we get the color images, we'll be able to get a sense of that sort of classic pinkish color, because that's what the glow of hydrogen, when hydrogen gas is excited by the young hot stars in these young clusters, it causes the gas to glow this beautiful red color. And so as we speak, we're collecting those photons of light. They're coming from a distance of a huge distance away. But this cluster is only about 2 million years old. So 2 million. I mean, this is what I love about astronomy. We always talk about we time travel in astronomy, but this particular cluster, 2 million years old. I mean, go back to what was happening, 2 million years ago on the Earth. It's quite extraordinary to think that an entire cluster of stars that we could see in space didn't exist before then. This is what I love. So hopefully we'll get these live images. I think behind our heads, actually. I think isn't that the cluster sort of coming in?
Yeah, this is it. So we have finally witnessed these two star-crossed lovers successfully uniting across all odds, really, with the issues with visuals in the beginning and them traveling through and along. There being rainy places around, but in the Canary Islands, we are seeing the telescope representing Orihime T1 and the telescope representing Hikoboshi as Altair and T2. We're seeing them on the same object. We've seen them cross the distance. They crossed the Milky Way, and now they are both on this final object, NGC 6823, and it's really, as it comes flushing into color, like Will was sort of alluding to, it's going to become very cool to see what exactly that looks like for these in general.
And we should put it in context as well, is that what we're actually seeing, that little cluster on the right hand side, if you were to hold your hand out at arm's length, it would easily fit. Well, it would be much smaller, in fact, than your little finger's nail at arm's length on the sky. So, look at the density of those stars in that picture on the left-hand side, the sheer number of stars in this region of the Milky Way. And then just think about that wonderful milky, misty band that we've traversed over the course of this show. That's what we're seeing, those millions, thousands of millions of stars that we talk about in the Milky Way as this misty light. There they are, resolved in front of our eyes, and you can see them. And this is extraordinary to get that sort of perspective, I think. All these different magnifications, all these different levels that we've seen this evening.
Yeah, and that brings up a good point in that we see Vega and Altair in the night sky. We've seen them for a while. Our ancestors have made stories about them. And can we see objects like this with the naked eye too, or is this just a telescope object?
This would be a beautiful telescopic object. I'm not actually sure of its magnitude. I doubt you'd see it with the naked eye. Many of the clusters in the Milky Way you can see with the naked eye. In fact, the one that we visited just a little while back, it's very close to the coat hanger. If you remember, we showed you a beautiful picture of NGC 6802. Well, there's a little cluster of stars. It's not thought to be actually a cluster of stars in the way that we've been talking about. Maybe a group is a better way to describe it, but it's called the coat hanger cluster. And NGC 6802 was right next to that. So you could see that with the naked eye, but you'd need a telescope to then go and see NGC 6802 in more detail. But I think this would be a more telescopic object. I don't think this is a naked eye object.
And so, as we're sort of wrapping up this journey, there's strife and drama associated with this story. These are two stars that Orihime's own father was the one who actually arranged the marriage between Orihime and Hikoboshi. But because Orihime started slacking off in her work and didn't weave as much as she should have, the father separated these two. At the same time, because of the sadness that came along with this separation, he did relent. He did take pity on these two people that were so obsessed with each other that they couldn't get any work done, and at the end gave them this one day where they could meet if the weather conditions were right. That a bridge of magpies would form and they could across the night sky to see each other. And so that's what we have been trying to visualize here tonight. And with these magpies, our Slooh magpies, are these different objects, these globular clusters, these open clusters, these nebulae. These two stars have been crossing the cosmos across steps of birds that are really so much relics of our own past and our own evolution through our own solar system. And so it's been really an incredible journey to take, and I'm happy that we were able to show you in the end of it all the uniting point that Orihime and Hikoboshi met with. It speaks to the trials and tribulations of lovers, and that sometimes throughout all the struggle and strife, in the end of it all, if you struggle hard enough, the both of you can come together, even if it is just for a moment. And if that moment is important enough, then it's something that you'll put in the effort to do. And that speaks a little bit to also what a lot of people do to celebrate Tanabata, is that they make wishes for their own health, for others that they care for. This is a celebration where wishes are put on paper and tied to branches, that sort of thing. You can see right here. This is an example of a lot of the festivities that go on in Tanabata, and that you see these trails of streamers along trees and things like that. And along those streamers, you have little papers with wishes. And we here at Slooh have a wish for those that are out there and enjoying and celebrating Tanabata. Mina no yume ga kanaibai. May your dreams come true. May your wishes come true. And we're so happy that you have come and joined with us to celebrate this intermingling and intermixing of culture and astronomy. It's such an important part not only of our history, but of our understanding of the sky. And so, as we're sort of wrapping up here, Will, any sort of last thoughts on this amazing journey that we've been able to take through the stars tonight?
Yeah, it's been a journey across the night sky, but in some ways we've also sort of journeyed forward in time in a way. We started out looking at those ancient objects, the globular clusters that sit above and below the Milky Way disk. Then we came sort of forward in time and we looked at the younger open clusters of stars, those young gatherings of stars, and then we finished up here with this beautiful object, this cluster associated with this nebulosity from which it and numerous other stars form. So, yeah, I think it's been a journey in time and space, hasn't it?
Really has, and just to make sure mention the behind the scenes, these are telescopes that have just recently been inaugurated by the King of Spain. These are telescopes that have seen a lot of history and a lot of culture, and we're so happy to be able to bring that background to you. And so thank you so much again for joining us. We have shows that are just coming up. A couple more in just a week's time. We have our call-in show coming up this Thursday, and we have the New Horizons. Its closest approach to Pluto coming up in just next week. And so look forward to those shows as well, and we will be on the air again before you know it. But for now, this has been Will and Eric for Slooh. We will see you again.